Hi, everyone. Chris Guzmal here. We're going to be doing some engineering, technology, and computer-aided design. To begin with, we want to learn little bit about logic circuits, because this is sort of what engineering, technology, and computer-aided design sort of begin with, which is to say, there's the juncture of things like symbolic logic, coding, and reality. And so in engineering technology, we work to create reality. And so we're gonna, because we're online, we're actually a little disconnected from reality. So the best we can do is to try and build some logic circuits. And so we're going to use the free trial version of Logically. I'm not forbidding you from buying it, but my goal here is to make this something that anyone can do. And you can go to the Logically in your browser here. If you look here, sort of this region down here, I click on that. And I'm not going to worry about these examples. You could look at these examples; they can be interesting, but I'm not going to ask you to even do that. I'm just going to say we have this main screen here, and on the left we have a number of things. We have input controls, toggle switches, push buttons, clocks, high constant, low constant. Some of these will make sense to you, some won't necessarily. The clock is probably the most mysterious one. Don't worry about it right now. Output controls, which are this weird 4-bit digit thing, and we have a light bulb. Light bulb is going to make the most sense to us today, and some logic gates, and we're going to explore those as well. So let's think about what's going to go into a logic switch, a logic circuit. We're going to have something like a toggle switch. Okay, a toggle switch is just a switch. It can be on or off. That's what toggle switch means. So I'm going to have 3 toggle switches. Okay, you can think about, well, how many different ways can I set my toggles? This first one could be on or off, the second one could be on or off, the third one could be on or off. How many different ways are there to do that? Sort of an interesting question if you're mathematically inclined to explore. But if you're not, well, whether you are or not, I don't know. But I'm going to now take 2 other kind of randomly chosen gates. I got a AND gate and I got an OR gate, and I put them into my circuit as well. So now I'm just going to connect things up. Oops, I tried and failed. Let's try that again. There we go. So just connecting up the circuits is pretty straightforward. I just take the output, take the value from the switches and put them into the inputs for the gates. And these 2 gates, I'm going to have them potentially affect a light bulb. Okay, actually this output's going to go to the input of this gate. Come on, Chris, you can do it. Oh my gosh, why isn't this working? Yeah. Lovely. It's just motor control issues. We'll talk about motors. So the light looks like the switch is on because the light's on because this switch is on. When I turn this switch off, the light turns off. I turn this switch on, the light stays off. I turn this switch on, the light turns on. So there's some different combinations. If I want to find out all the combinations, I can click here on the truth table. And it only shows me for light 1. I don't know. I thought there would be a way that there should be a way for me to see all of them. So yeah, if I click in the right place, then I can get all the possible values for switch 1, 2, and 3, or input 1, 2, and 3. That's what these are. Those are I's, and then output 1. And true means that the light bulb is on, and false means the light bulb is off. True means the switch is on. False means the switch is off. And you can even, looks like you can even export that, and you could even turn that in as part of your assignment as a bonus. Maybe I'll have you do that. But that's how you build a logic switch in Logically. So your goal is to take a screenshot of this. Actually, even better would be to send me the truth table and to write a sentence, 1 sentence basically saying, I want to build this, or I want to write code for this. Those are 2 ways we could attack this as sort of the next stage in your engineering training.